welcome back to Art Bar. Here's the main speaker, and thank you very much for joining us today.
Hello, everybody. I'm really happy that I can stand here and have this talk. So today the topic will be about easy service-to-service communication using Pydantic models. So I hope you will enjoy it. So in the beginning, some introduction about me. So my name is Michal Korbela. I studied Masaryk University Faculty of Informatics that is behind this corner. And currently I'm working at kiwi.com over 4 years. I basically played the key role in establishing the flow of the baggage from the sources through the storage. And today I should speak about the communication between services to clarify all the terms. I'll be speaking about typical client-to-server communication with this typical for the microservices architecture. So no peer-to-peer or other types of communication. And I will start with the problems or incidents we had in our company to basically define the problem I would like to solve. So first, most often happening incident is outdated documentation. Yeah, do you know what's the difference between code and its documentation? Code is always right. Yeah. So another thing that we have problems with it, typos in field names, usually in most cases optional field names, because your service assumes that there is one field is optional, so you don't have to provide it. But if the client sent to the server some data and the field is named differently, like for example we assumed it is sector name, but the client sent sector ID or just sector. The client basically thought that it sent the correct field and the data was there, but the server didn't recognize it. But since it was optional, we didn't detect it. Another problem was incorrect validators. So for example, we added some value to the enum, but we didn't change the validators. So we deploy it, and we suddenly found out that everything works, just the validators stop accepting the values that should be there. And of course, difficult reviews. If you would like to add one field somewhere, my colleague do it, and I need to review it after him. And the problem is very difficult to basically check if all the places were basically changed and nowhere it was forgotten. And basically, what's the common problem of all these issues? Maybe one may think that it is like human mistakes. And the question is, do we need to really push to the developers that they need to be careful, or even do we need to punish them for all these kind of mistakes? The answer is no, we shouldn't do something like that. And the solution, how can we basically solve or prevent these kind of issues, is to use tools. We have tools for checking of this kind things, so why not to use them? So the first kind of tools we can use are static analyzers. Probably many of you already heard about these tools. The first one is Pylin, that is a static code analyzer, and it checks code for the syntax, for code standards, so it checks if you didn't forget import the library before you use it, or declare the variable before you use it, or if you define a variable, it is not a function, you cannot call it. Another linter is MyPy that basically checks for all the types in your code. If you know type annotations, those are those types next to the names of the variables. I really recommend to use them because this tool then can help you to check your code if you are not passing string to the function that expects integer, for example. However, these tools are not perfect because they have some limits. These tools, for example, cannot check keys of dictionaries. If you construct a dictionary, it has some keys, and then you pass it to a function that expects that you have some particular keys in the dictionary. But this cannot be checked by these linters. So the solution is to use, in those cases, models instead of dicts. So for example, data classes that are built in Python, or use Utter's library, or Pydantic that I will be talking later. Another thing that cannot be checked by linters is parts of the project that are defined not in Python files. For example, if you have experience with YAML APIs, you often define the API in YAML file in the OpenAPI format. But in that case, the linters cannot check the OpenAPI file and tell you if there are mistakes or not. And another thing is dynamically generated classes. If you have a function and that function will return, like construct a class and return it, not object, but class. In that case, the type of the class is not detected by the static code analyzers, and basically those tools cannot check it. So, of course, there are other kinds of problems that these linters cannot check, but I mentioned just these three because they will be important later. So try to avoid these kind of problems, and the linters will solve many of the problems for you. Second thing, since I will be talking about, or I should talk about the communication, is request between services. In this example, I will use post request because GET is simple, so let's take the more complex one. So in case of post request, there should be a documentation hosted by the server how the request body should look like. Then the server will construct the request body, according to the documentation, send it to the server will validate it, and parse it to its own internal structures. Similar, it is for the response body. There needs to be documented the response body object. Server will construct, according to this documentation, the request body object and send it to the client that will validate it and parse it to its own internal structures. And if this is not done in any smart way, how many places do you need to touch if you would like to, for example, add one field to, let's say, the request body? You need to touch the documentation, construction, validation, and also parsing. So you need to touch basically 4 places. The similar it is for the response body. And do you know how difficult it is to maintain such thing if it is spread on 4 places? And how difficult it is to not forget to some of these instances? Maybe one may think that this was like really done in a really stupid way, and in normal situation it doesn't happen like that. But I will give you an example. We had services written in Flask, and we used Connexion library for handling the requests. In Connexion, the API schema is defined as OpenAPI file in YAML file, and it basically validates the request and also provides the documentation for it, but nothing else. So popular packages Connexion, it has 4.1 stars, but basically if we use it, we basically reduce the 4 places for the request body and 4 places for the response body, just for 3 places for the request body and 4 places for the response body. So if we use this package, we basically didn't do any significant improvement. So maybe one may think that how it will be with Django. So we had also service with Django, and we used Marshmallow library, it is also popular, and DRF YASG library for connecting it with Django. In this case, the schema is defined as a Marshmallow schema, and basically it provides the validation and also the documentation. And in this case, again, you pass the raw dict into the function, so the function needs to parse the request body manually. So again, in Django, the request body is defined on 3 places, and the response body is defined on 4 places. So again, any significant improvement. Here I will introduce Pydantic. Pydantic is a library that basically, I don't know if you see that. Okay, so basically it's a library where you can define models, and for each field you define its type by normal typing annotations. You also describe you can define their default values, examples, descriptions, some validators, etc. And then you basically get a model and you work with it as with a normal Python object. And why I mentioned Pydantic? Because there is Fast API, and it's a framework that is based on this library. And in Fast API, you basically define one Pydantic model for request and for response. For simplicity here, I use the same model for request and response. And Pydantic Fast API can basically take the model and use it for validation of the request body, generating documentation for the request body, and also parsing the request body into the function. So here you can see the function gets directly the object and don't have to care about parsing the JSON. Similar it is for the response. Basically you just construct the object. You can make there any typo when you are constructing the string keys of the dictionary, and it automatically serializes it and send it to the client. So in this case, it is much simpler with those previous libraries. But since we were using services written in Flask and Django, I was looking how it can be improved there, because those libraries doesn't have anything built in like Fast API. For Django, I found that there is a really nice package. It's called Django Ninja, and it adds all the missing functionality of Fast API about request handling to Django. So you can use Django similarly as Fast API. You define a model and use it for a request validation, auto-generating the documentation, and also for parsing the request body. Similarly for the response body. For Flask, the situation is a bit difficult, because I was thinking that Flask is a popular framework, and the similar package as for Django will be also for Flask. But it's not like that. I checked many packages. First is the connection, as I mentioned, but it just validates the request body and provides the documentation for it, but it doesn't parse it, and also you need to basically respond with a raw dict, and it even don't validate it. There is a similar package, it's called Flexer, but it has the same issues as the connection. There are other packages as Fast Pydantic. It can parse the request body, also validates it, but it cannot generate documentation. There are other packages as Spec3 and Flask OpenIP3, but in those cases, you need always to return a raw dict. So you need to basically deal with the raw dicts that I mentioned in the beginning of the presentation, that they cannot be checked by the linters. And really, there isn't any such package as the Django Ninja for Flask. So the only option I had was to basically create my own package. I call it Flask Ninja. I was heavily inspired by the Django Ninja package, so therefore I call it like that. And it works pretty similar as the Django Ninja. You define a Pydantic model and use it in all the places where you can. So to sum it up somehow, if we basically try to use this either Fast API or Django Ninja or Flask Ninja, we used one Pydantic model for everything what was on the server side. But on the client side, we also had to, in the case of a request body, we had to construct it. And in the response body, we had to validate it and also parse it. So it was from the counts 3 and 4 reduced to 2 and 3. So it's much better. And the question is, can it be somehow improved? Of course, yes. As you see, the main issue is that everything is unified on the server side, but the client is a bit separated. So once we have defined the request objects and response objects as Pydantic objects, why cannot we share it with the client? So client can basically take them and benefit from them. So you can share basically the Pydantic models with the client, and the request body can be used in client to construct the request body object, and on the server side to parse, validate, and auto-generate the documentation. So you define it once and use it everywhere. For the response body, on the server side, you construct the response body object and auto-generate the documentation, and on the client side, you validate the response and parse it. So for each basically field, it holds that it's defined in one place. So if you would like to add something or change something or remove something, you need to touch only one place. So it's basically a huge improvement from the 4 and 4 counts. So now we have defined all the basically models as Pydantic objects, and they are shared with all the services. But to make the communication with the services more convenient and better and beautiful, and increase the developer experience, there is some pattern called API client. Imagine that you have defined the Pydantic object for the response body, and how you will basically use it in one client, in service 1. You will basically do something like that. You will use some, let's say, requests library for fetching the data. It will return you the JSON, and you will parse it by the response body object. How you will do it in the service 2? Probably the same, because you would like to obtain the same data. How you will do it in the service 3? Probably in the same way. And the question is, can it be somehow unified? Because you don't want to basically deal with the same thing in each service. And of course, this is the easiest example, but there can be authentication, there can be many headers, and so on. So if you not improve it, you will always need to deal with in each service with the same stuff. So imagine you will write this code into one function and call it my service client. This class will have one method, and that method will take the data from the API and return it as an object. Then you need basically just to call that method. And if you share also this class with all the services, they use your API. They basically can deal with your API in this functional way. And if you are using clients, you basically even don't know that you are making any HTTP calls, because you just call a function and it gives you the data. Of course, when you are dealing with HTTP calls or API calls, you need some advanced stuff as retries, because the network is not always working. You need to retry this a couple of times. You need, for example, some logging of the requests. You need some monitoring, error handling. And in that case, if you do it in each service by your own, you will basically do inventing wheel, because it can be somehow shared. In our company, we use the request session package that basically have all the common features already implemented. It's logging, monitoring, request error handling. If you know Sentry, it also can report all the exceptions to the Sentry. It also supports retries, and you can configure there many other parameters. So you don't have to deal with it on your own. You can use this package, and it solves everything for you. It works in a way that you basically create a client for your basically API, and then use it for any endpoint you want. How we implemented this client in our clients? We basically created some base client. Probably it's not visible, or it is. And so basically it has some parameters. So you can instantiate the request session object, and then just you will extend this base client with any client you want, any methods you want. So for example, in our case, we have a backpack service, and you would like to fetch some endpoint. So you just extend the base client, specify their URL, client name, I don't know if it is visible, authentication, etc. And it solves for you all the things as retries, logging, error handling, metrics. It also checks, measures the time of the request, so it also logs that. So basically everything what you need for about your request is solved by this library. And it really simplifies dealing with the APIs. In the end of my talk, I would like to just mention one really amazing package. It's called Pydantic factories. If you have some experience with factories, as SQL Alchemy factories, etc., you need to basically write separate factory with all the fields you would like to generate the data. But in this case, if you are using Pydantic and Pydantic factories package, it can take any Pydantic model and extract the information about the fields from it. So you don't have to define for each of the fields how the data should be generated. If string needs to be there or int, what are the ranges. It automatically detects it from the model. So this is the usage of the Pydantic factories package, and it populates the model with random data. It's mostly useful in tests. Here are the links for the projects. You can check them later after this talk. And if you are interested in any of the packages, feel free to use them. And otherwise, that will be all from me. And I would like to really thank you for your attention. And if you have any questions, feel free to ask either here or after. Thanks.
Thank you very much. So, question time. Do we have any questions? There's some.
Yeah.
How do you deal with updating the command client for the multiple services? Because we had a similar issues, and when we updated the client, we had to deal with several other things to roll the base client to all the services.
If it is like a critical update that it needs to be updated, we usually need to update it manually, but we are using renovate bots or dependa bots, these kind of tools that automatically update dependencies. So if it's not that critical, you just wait a couple of days and it will automatically update the version there.
Okay, and we have some guidelines how to write non-breaking changes in the clients.
Usually the non-breaking changes are when you add some fields, because yeah.
Some guidelines so all the developers can stick to that, or you just learn by.
If it is a non-breaking change, it's adding field or removing unused field, or if you'd like to change it, you need to at first deprecate it in all the clients and then remove it. So, there is just this, nothing.
Okay.
Yeah.
I got two, but I will postpone the other one.
Yeah.
Are you familiar with GraphQL?
Yes.
And don't you have the feeling that you are kind of rewriting GraphQL right now? Because the point of GraphQL is that you have the scheme at the server, you have the client which downloads the scheme and generates these clients, and you don't even have to then deal with the problem of how to push new clients to the client because they generated themselves from those schema served at the server. So my question is how is this different, or how is this better than using GraphQL?
I don't have experience with generating clients for GraphQL, so
You can use Apollo client and download the scheme and generate all the cool stuff.
I think the difference can be the typing. That here you have basically the types already there, and
The GraphQL schema also got types. Yeah.
Okay. So in that case, I need to look at it and compare it. From this point of view, I cannot answer.
Its own set of problems, but the problem you are trying to solve right now, the GraphQL really solves that problem really good. But it gets all the other problems which REST doesn't have, so I don't really want to do that.
Yeah.
But maybe look at that.
Okay.
This might be a case where you are in a position where you can't migrate to GraphQL. There are certain places where you just cannot. So unfortunately,
that was the question. How this compares to GraphQL? Are you reinventing it? One point for using this is that you don't have to abandon the rest, which is a huge advantage.
One more thing I forgot to mention, that also from Pydantic you can generate the OpenAPI schema, and there is a package called OpenAPI generator or something like that it can generate client for any package from this API schema, OpenAPI schema. But the problem is I tried it yesterday and it generated tons of code like for like a couple of endpoints, it generated thousands of lines. So theoretically, you can also, like, one argument against this was that you can have define the schema of the API in the YAML file and generate from it any client for any language. But the disadvantage of like this OpenAPI generator is that it generates the clients in like a really shitty way. So if you'd like to have a clean code, and so therefore it's not suitable for that.
Does this aim for a clean code? Because imagine that you have this endpoint, and you can have a lot of query parameters. You know, like omitting fields, adding some nested things to it. And the way this works, if I understand correctly, you generate separate object to represent each of the variants you can create by using various.
In Pydantic or where?
No, your solution.
Yeah, here? No, you just specify the field as optional.
Oh yeah. So optional.
Yes, as optional.
Thanks.
Yes?
So I've got a question. You talked about linters, static checking. What about unit testing?
Unit testing and
Well, you talked a lot about types and the kind
Yes,
of
yes, yes.
responses you expect and get. Like, technically speaking, on the level of the interface between the individual objects in Python, you can test this with simple mocking, right? So you're doing that as well, I assume.
yeah, like one disadvantage of like unit tests that is that you need to mock a lot of things. So if you, for example, change API, you need to change it in many places, and you may not be sure if you changed it everywhere.
Well, if you don't, then the test will fail, right?
Yeah, but you need to, yes, but you need to, for example, change it to the new behavior, which can be wrong. It happens, I was refactoring a lot of code recently, and I had to change like 100 tests. And basically, I was fixing them in a way that to make them passing. But it happens many times that it wasn't correct because the behavior was wrong, and I was just making them passing. And it can happen if you are refactoring a lot of tests or fixing them. So yes, of course, tests are important, and you need to use them. But they may not say, they may be, let's say, outdated. If you change, you do some breaking change and you change something significantly.
And you can always change the test wrong, right?
Yes, exactly. So they are not representing the expected behavior.
Especially if you are the developer developing the feature and also testing the feature.
Yeah, exactly.
Then you develop the feature wrong, develop the test wrong, and everything works.
Yes, exactly. All the tests are passing, but your service is not working.
Then I have a question.
Yes.
You mentioned that you share with client the Pydantic model, right? How do you share it? Is it the internal client, the within the company, or clients as external companies?
Yeah, this particular, like in our ancillary team, we have ancillary clients package. It's internal package, and in case you have monorepo, you can have it like a package. You don't have to publish it anywhere. But in case you are using multiple repositories, we have, for example, for that case, internal PyPy, and we publish the packages there. So whenever we change it, we publish it there and share it with all the services they need.
And also public?
It's not public. This one is internal. But for example, the request session package that handles all the retries, monitoring, logging, everything is public. So all the packages I mentioned here in the links, they are public. So you can try and test them.
We haven't had a good flame war for a while. So do you use Black or any other?
Oh, of course, we use pre-commit with many linters. But
okay, so automated format.
Yeah. Like we really require high code standards.
Okay,
So
we had some strong opinions before in these discussions.
really? So maybe we can discuss it
You
after.
won't believe how much bad code actually passes Black, pre-commit, all the linters.
I know, I write it.
Because at some point you arrive at the stage that I just need to push this code. I don't really care.
Cool. Any other questions? Good, so are you staying with us for a while?
Yeah, I can, definitely.
Good, then hopefully you can talk to Michal after. And thank you very much again.
You're welcome.